Good morning for everyone. My name is Ivanka Veneva, and I am from the Institute of Mechanics, Bulgarian Academy of Sciences. I want to present you the rehabilitation device for lower limbs through virtual training and electrical acupuncture stimulation. The research was funded from the National Innovation Fund under the project Development of an Innovative Solution for Rehabilitation After Cerebrovascular Accident or Spinal Cord Injury. During this project, our team has developed a non-invasive multi-electrode neurorehabilitation device to stimulate various acupuncture points on the leg or hand by applying electrical impulses. The developed neurorehabilitation system aims to find application for the rehabilitation of paralysis and to restore the natural movement of the patient's limbs in case of spinal cord injury.
Sorry, Ivanka, it seems we have a problem. It's not advancing the slides. Can you just wait a second? So are you still in first slide now?
Sorry?
Oh, now it's okay. Please go ahead. Yes.
Is it okay?
Yes, yes.
Okay. I'm not sure if you see my video or my face or only the presentation. Okay, let me continue. So the developed neurorehabilitation systems aims to find application for the rehabilitation of paralysis and to restore the natural movement of the patient's limbs in cases of spinal cord injury. We want to understand the effect and possible benefits of electrical stimulation on the acupuncture points of the foot or hand, as well as whether it can improve rehabilitation of paralysis. In the process of rehabilitation and during the experiments, the available active exoskeletons are used to support the movements of the human limbs and for motion capturing. The movement of the participant are monitored in real time through the system of position sensors and electromyographic sensors. The results of the active exoskeleton experiments have already been presented at several other conferences. The aim of this presentation is to present a prototype of device for electrical stimulation developed during the project. The described prototype of device is used to study healthy subjects in our laboratory and people with spinal cord injury in a specialized clinic that cooperates on the project. Here you can see the developed prototype of the multi-electrode matrix for stimulating various acupuncture points on the legs or hand by applying electrical impulses. Graphical user interface with interactive communication has been created to adjust the strength and duration of electrical pulses. The designed system provides real-time visualization, adjustment, and feedback, guiding the operator in the steps of the therapeutic procedure, which makes rehabilitation therapy more adaptable to the patient's personal characteristics without creating inconvenience. Here you can see the diagram of the graphical user interface. The developed neurorehabilitation system is intended to affect the nerve pathways through the receptors of the foot and hand and the appropriate acupuncture points with electrical stimuli. The electrical stimulation is performed on the surface of the skin with the help of electrodes fixed on the matrix and with the terminal for connection to the control device. The graphical interface allows to modulate the intensity of stimulation during rehabilitation and to monitor changes in limb behavior. The multi-electrode matrix makes it possible to act on selected acupuncture points by distributing and activating the electrodes. All stimulation parameters are determined depending on the maximum sensitivity threshold and the characteristics of the patient's sensory system. These are frequency, minimum and maximum intensity, pulse duration, synchronization and order of stimulations, type of user interactions, and number of repetitions. Here we can see the diagram with the button for selection. We can select the foot or hand diagram with distributed acupuncture zones and with the following functionalities: fields of setting the electrical stimulation parameters, interface elements. These are 40 electrodes for activating electrical stimulation at certain acupuncture points, positioning the electrodes on the limb diagram, buttons for control and connection to the device, and start and stop of electrical stimulation. We have constant output signal with voltage level setting, output voltage control, and implementation of electrical stimulation and control of electrical impulses, and status monitoring. Here you can see the control algorithm with 3 parts. This is communication via serial interface, control and communication, and start and stop of electrical stimulation. The description of control unit is on this slide presented, which consists of microcontroller, driver unit, power supply, voltage regulator, interface for communication with the computer. The microcontroller acts as a transceiver communicating with computer software and controlling the output voltage of the haptic driver with integrated boost converter. The voltage is applied to the input of the high voltage 64 channel series parallel converter, where it is distributed to the corresponding output electrode with certain pulse width modulation and signal frequency. The controller can control up to 64 electrodes simultaneously. The device is designed as a driver with a multi-output high voltage source with low current, which is regulated depending on the different value of the skin electrode impedance. To ensure maximum protection and comfort of the patient, it is possible to stop the procedure at any time and turn off the equipment. During the experiments, experimental testing of the functionality of the device and specification of the main parameters of electrical stimulation of acupuncture points were performed. These are voltage regulation from 0 to 100 volts, frequency adjustment from 1 to 40 hertz, duty cycle from 100 to 200 microseconds, pulse duration, type of user interaction, number of repetition. Here we can see the experimentally generated output signal controlled by the graphical interface. The experiment and data collection were performed on 5 subjects and obtained results were analyzed. During the experiment, the exoskeleton is used to support the movements of the lower limbs. The movements of the participants are monitored in real time through a system of sensors for position, force and pressure, as well as electromyographic sensor, which give a measure of the muscle force. The first experiment was performed without external assistive force applied by the exoskeleton, rotation in the hip joint while the person raises his left leg and holds it at about 90 degrees. The second experiment was performed with external assistive force of 15 Newton meters applied by the exoskeleton or 4.5 bar applied through the pneumatic actuator. Here you can see the hip rotation with and without assistive, active assistant from the exoskeleton, and measured muscle strength by electromyographic sensors. For the conclusion, I would say the aim of the paper is to present a device for electrical stimulation, which allows the stimulation of selected acupuncture points of the human foot or hand using pulse width modulation during the stimulation cycle. A control unit and a multi-electrode matrix built into the insole have been developed. A graphical user interface for adjusting the electrical stimulation makes it possible to act on selected acupuncture points by distributing and activating the electrodes and to determine all parameters of the stimulation: frequency, minimum and maximum intensity, pulse duration, synchronization, and order of stimulations, type of user interactions, and number of repetitions. The user interface contains instructions and additional information for each of the functions of the device, for control procedures and operating modes. There are also arranged steps to indicate to the user the methodology of operation. Protection and emergency shutdown are provided. Several experiments with volunteers have been conducted to ensure maximum protection and comfort of the patient. It is possible to stop the procedure at any time and turn off the equipment. This research was funded from the National Innovation Fund under the project Development of an Innovative Solution for Rehabilitation after a Cerebrovascular Accident or Spinal Cord Injury, and supported by the Operational Program Science and Education from Smart Grow. Thank you for your attention.
Presentation. Very interesting work. I don't know if there are any questions.
Can you hear me? Thank you for your presentation. Can you hear me?
Yes.
Yes, okay. I have two questions. And the first one, which is the technology used on the electrodes? If they use gel or not? Or
the technology for what?
The electrodes for the stimulation.
For electrostimulation?
Yes.
What exactly do you mean? We use the electrostimulation.
Gel? They use gel or not?
If there is gel in the electrodes, if they are dry, what type of electrodes you have?
As I show, this is our matrix with electrodes. You can see here a matrix with, for this insole, we use 40 electrodes.
Okay. And the second question is, how do you adjust the stimulation parameters, for instance, the intensity? Are they adjusted in real time?
Yes, this is adjusted in real time, and we use pulse width modulation for adjustment of the voltage, of the output voltage, and current, low current, which is applied to different electrodes during the electrostimulation. During the electrostimulation, we can stimulate the selected parts of electrodes. We can select 1, 2, or 3 electrodes, and we can select all 40 electrodes together and stimulate in real time. And in the graphical user interface, we can obtain and see in real time the parameters which are applied and which are used during the experiment.
Okay, thank you.
Thank you. Are there any more questions? So, Ivanka, just to finalize, how do you deal with the sweat and things like that? In the electrodes, you have this problem of if you sweat, you know, if
the electrodes are dry.
Okay. Okay, thank you. And could you just elaborate a bit more on the connection with the exoskeleton? So is the adjustment of the stimulation in some manner related with the assistance that you provide with the exoskeleton, or there is no connection?
You want to say something more about the exoskeleton? Here?
If you could elaborate a bit more which the assistance that the exoskeleton provide, if it is somehow related with the intensity of the stimulation that you give, or no.
I cannot hear you very clear, but so I can explain. We use the exoskeleton for support the movements of the people who are, of course, disabled, more or less. So the exoskeleton which we use is with pneumatic actuation. So we can use this exoskeleton together with the virtual reality engine. We have made several scenes with virtual reality under the 3D Unity engine. So during the experiment, we use the exoskeleton for assistance. And also this exoskeleton can apply, we can apply for assistance or for resistance. So we can make assistance during the experiments, and we can apply pressure during the experiments. And after that, we measure the angles of the hip, knee, and ankle before the electrical stimulation and after the electrical stimulation. In this way, we can obtain the results which are during the process of rehabilitation. We can see if this rehabilitation helped the person, and if we have good rehabilitation during the process, if this helped the person, and so on.
Just to finalize, do you have, I mean, it was difficult to get an ethical approval for this, and when you do it with patients, was it difficult to get this ethical approval using electrical stimulation? Or?
Sorry, I cannot hear you very clear.
Okay, just. I was talking about.
Could you repeat the question? But slowly, please.
Ethical improvement. If it was difficult to achieve ethical improvement.
Is it difficult to achieve control?
Ethics.
Ethical?
Yes, exactly.
Ethical?
Yes.
Yes, of course, we have the committee of ethics, which allow us, which give us permission for these experiments.
Okay. Thank you so much. It was that, Ivanka. Thank you so much for your presentation, and congratulations for your work.
Thank you very much for your attention.